In this video, we're going to talk about the rules of exponents, but let's begin with a simple definition. It says that if a is a real number and n is a positive integer, then a to the n power means a times a times a times a with a total of n number of factors. Okay, so there are n factors here. Okay, so as a first example, let's look at 5 to the third power. What that means, according to this definition, is 5 times 5 times 5, which is 125. Okay, so let's look at some of the rules. The first rule says that a to the n times a to the m is equal to a to the n plus m. Now, why does that work? Well, I think we can see this with an example. According to the rule, 7 squared times 7 to the third power should equal 7 to the fifth power. But why is it 7 to the fifth? Well, remember, 7 squared just means 7 times 7. And 7 cubed means 7 times 7 times 7. If we remove the parentheses, what we see is we have a total of 5 sevens. Right? This is 7 to the fifth power. Okay, so you can see why we added the exponents. We had a group of 2 sevens and a group of 3 sevens, and when you remove the parentheses, you have a total of 5. Okay, so that's why we add exponents in that case. All right, now the second rule says that a to the n raised to the mth power is equal to a to the n times m. Now, why does that rule work? Well, here we see 7 squared cubed. According to that rule, it should be 7 to the sixth power. So why is it 7 to the sixth? Why do we multiply those exponents? Well, 7 squared to the third power really just means 7 times 7 to the third power, because that's what 7 squared is. And 7 times 7 to the third power just means 7 times 7 multiplied by itself 3 times. Okay, so what you have here is a total of 6 sevens, which is 7 to the sixth power. Okay, why did we end up with 6 sevens? Well, we had 3 groups of 2 sevens, and 3 times 2 is 6.